So let's get started. So the first question is, why MDT? Why model-driven telemetry, right? And there are many reasons. So, back in the 90s, right, it was awesome to go into a CLI. And, back then, MIPS was a big thing. Things were going great. But then, we started evolving. Yeah, CLI and MIPS was not enough. Then we got into syslog. We got into traps. Then we got NetFlow, SFlow, you guys name it, right? A bunch of stuff there with the flows. But now, the new journey and where everything is taking it forward is with streaming telemetry, gRPC. And that's where we're seeing the market trending, moving towards streaming telemetry. There are other reasons, right, why people were looking for something better. And it's because with SNMP, we're having a lot of false, positive alarms, a lot of retransmission. It was not very accurate. Sometimes people were getting, up at night with those kind of false alarms that were not problems on the network, but it's because the tool was not getting the right data from the devices. And that's why some customers started looking for other solutions like streaming telemetry. It all started in the application first, right, on the app side, right, with software developer adopting gRPC, and then it moved towards the network side. And then the other thing about why people are actually moving to MDT is because of scale. And when we talk about scale, we're talking about probably hundreds or thousands of sites, right? Where you actually are reporting from all those sites, all your data to a centralized place. It can be in the cloud, it can be on-prem, right? So it's everything about scale, right? If you want to be able to go beyond with a certain number of sites and you want to really get accurate data, then model-driven telemetry will be the right way to go. And then the other reason of this is less monitoring and management tools, right? You just can't forget about those many dashboard having so many different tools, open source or even provided by a vendor. And then forgetting about going to the CLI or pulling data directly from CLI or even SNMP, right? And then the other compelling story is that now people are also moving towards automation tools. So gRPC can be the avenue that can give you all those metrics and KPIs that you need to build better automation tools around the network. And this is where we believe this is the North Star. This is what we believe is the end goal where customers should be moving towards. Have a good strategy about MDT. Syslog, we still believe have a big play here on it. We also believe that in the future, even encrypting those logs, that information on Syslog is pretty important. And then building on top of this, with netconf, resconf, or even APIs in order to communicate with the devices, in order to communicate, in this case, with the wireless LAN controllers. And then at the end, you're getting more data, more accuracy, and way more flexibility on how you can consume those stats, those metrics, and those KPIs. With SNMP, the consumption of this data is very limited, but with gRPC, it's way more richer, and you can go even more granular on how you can consume all of this data. And then, you can build your own reporting the way you want it with many different tools in the cloud, and even with different vendors, and do all sort of integrations around, notification, ticketing, alarming, and all that. Now that we know the why, we will get into an introduction to model-driven telemetry, what MDT means, and what is the value of MDT around all this. So on iOS XE operation today, we support netconf, we support resconf. We started the support of GNMI for dial-out in 17.11. We actually do support GNMI dial-in from 17.12, but we started the support for dial-out in 17.11. And also, we support gRPC as well. We started having full support in gRPC on 17.9. 17.9.3, it was the most stable code when we started supporting gRPC. And then, but for today, we're going to be focusing on gRPC. That's where we're going to be putting all the attention, right, for MDT. So there are two ways that you can actually consume model-driven telemetry today. The first one is with GNMI. The second one is with gRPC. The difference between GNMI and gRPC is that with GNMI, you can do direct dial in and dial out. And your YANG models, actually, with GNMI, are not living in the device itself, are actually living on the control is on the master GNMI server or collectors, let's put it that way. And then GNMI will be dictating to your devices what information you need from the network. In the case of gRPC, which is dial out, right? Those different YAM models or XPaths are living in the device, so you're just defining your device, what is the configuration that you're requesting, right, from the device to be sent out to your collectors. And then you can set the time periods on how often you want to be able to get those different measurements or that you have defined with the XPath that you have in that device, right? And then from a gRPC application standpoint of view today, right? So the gRPC concept is nothing more than HTTP2, and this uses actually a TCP socket, right? That's number one. And then the concept of gRPC is basically to collect and send that data, as I mentioned before, or measurements to a remote server or remote receiver that you have on your network. The receiver, it can be like an IP address, or it can be a host name. In this case, you can define your FQDN strategy. We actually recommend to do it that way. So that way, you can define your load balancers or your collectors in case you're just using like few collectors, right? And that way, you send the data. Okay, and then you have there like the collectors. Then when you're going to be collecting, you have the collectors, but then where you're going to be storing that data, right? So you need to have your storage. And then how you're going to be visualizing that data, consuming that data, that will be on the application side. And then we have YANG and XPath. So YANG is a modeling language, right? So YANG basically models the config of your devices, right? And then the XPath is nothing else than YANG models that you are using in your devices with specific measurements that you want to take out of that device, right? So what you define on your controller is the XPaths. Those XPaths are based on the YANG models, and you have their specific measurements that you want for each of the XPaths that you have in your device. Okay. Now moving on, there are two types of publications, right? That we can do with gRPC. The first one is on change. So in case there is a change on the network, notify those specific measurements or KPIs to my collector. And the second one is based on a specific period of time. Based on a specific time, let's say 60 seconds, 90 seconds, 3 minutes, 1 minute, whatever. We don't support on change on all the XPaths, but we do support periodic on all the XPaths. So we strongly recommend to go periodic because the support on change is very limited and it's not supported in all the XPaths that we have available. And then the different components, as I mentioned before. So this can be very simple, but it can be a little bit more complicated depending on how much how much is the scale that you want to handle, right? So if you have a very complex network and you're thinking about scaling this to thousands of sites, so you can have a full model where you have load balancers, the collectors can be sitting behind the load balancers, and then you have a distributed storage across different sites or different regions in the cloud, if you like it that way. And then you can monitor based on different regions or centralize the monitoring of all your devices in a single pane of glass. So depending on how you want to build it and how far you want to go, there are different ways of doing this. This is just example of different tools and solutions that are out there, that you can use actually to build that strategy around model-driven telemetry. All right, so now we're going to the first question. If you know the answer, raise your hand. Which of the following is one reason why IT is looking to move towards model-driven telemetry? I think the person with the brown shirt, he was the B? You said B? And that's correct. He got it right. It was not too hard to get that answer, right? But you need to read it. I don't know how he got it so fast, but it looks like he, fast reader. All right, so now let's get into model-driven telemetry connection state flow. So now I will explain to you guys how gRPC works on the ASR in iOS XE, not the Catalyst, sorry, not the Catalyst or a specific ISR router, but in iOS XE in general, how model-driven telemetry gRPC works. So you have on the top connection flow state, right? And then at the bottom you have a disconnection flow state. So when you are actually on the connection flow state, you have a disconnect, then a resolving. And the reason why we're showing resolving here is because we strongly recommend we go with FQDN. We strongly recommend to go with the host name rather than going with an IP address. That way you can define multiple collectors. In this case, we have one host name that is resolving to 4 different collectors, correct? So when you do a DNS resolution of that host name, depending on your DNS strategy, it can be round robin, or it can be, okay, the first 10 connection goes to, let's say, collector 1. And then the next 10 connections or DNS query goes to collector 2, right? But let's say if you do it round robin, right, those are going to be going, let's say, to collector 1, collector 2, 3, and 4, right? So in this case, right now we're showing that everything is in connecting flow state, so everything is actually working as expected. So let's say now that you have collector 4, right? And for some reason, collector 4 went down. And in this case, you had 4 XPaths or 4 subscriptions that were on collector 4. So what will happen is that those subscriptions will obviously disconnect, and then this period of 15 seconds will start, right? Where you're going from disconnecting state flow, where you're connected, disconnected, subchannel is going to be released, then you're completely disconnected, and then again, the connection state flow will start, where each subscription will start that flow of 15 seconds. So the entire flow of disconnecting to connected, it would take 15 seconds for a subscription that was already working to go back to another collector because one of them went down. Okay, so in case now the collector didn't come back, then what will happen is that those 10 XPaths will try to will do the DNS resolution, right? We'll do again, the discovery of those specific IP addresses that are still there, and then it will do the subscription with the other collectors that are available on the network based on the DNS resolution that each subscription was able to do, because each subscription independently is going to be doing that DNS resolution in order to know to which IP address they should be sending the connectivity for the XPath to send the data. All right, so that's pretty simple and straightforward. So now we're going to the second question. What are the 2 publication types supported on gRPC for iOS XE?
C.
You got it right. So it's C. Nice.
Yes.
Awesome.
Always. Thank you.
All right. So now let's get into the next topic. Next topic is design considerations, right? So the first thing that you need to keep in mind when you're designing your model-driven telemetry strategy is secure your transport, right? So we strongly recommend we go with TLS or MTLS, depending if you want to have keys on both sides. It can be TLS, MTLS, but if you want just to have keys on the server side, then you can go TLS. There are customers that are using TLS, and there are customers that are using MTLS. So we strongly recommend to secure your transfer. We don't recommend to go plain text just with TCP, because nowadays data is key, and you're sending all the KPIs, metrics, everything about your network to a receiver. You want to make sure that that data is encrypted. The second thing that you need to define here is your FQDN strategy, right? It can be, the FQDN strategy is so important because you need to know if you want to send to each DNS server round robin, each connection or each subscription, or if you want to say, oh, I want to send it to one DNS query to this IP address that is on region A and this other IP address that is on region B, right? Or this data center or data center A or B. So your DNS strategy around your FQDN is pretty important, right? And then always think about redundancy. And when we talk about redundancy, this is pretty obvious. You need to have multiple collectors serving your MDT, all your devices that are doing model-driven telemetry. So you want to make sure that you have full redundancy just in case multiple collectors or one full region goes down. Hey, you know what? I still have redundancy to be able to send the data to another region that is available. In thinking about how to deploy this is an example of a cloud deployment where you have your controllers on-prem, you have your access point and everything, and then this is how you can build this architecture in the cloud. So define, obviously, your load balancers, if you have any, how your collectors are going to be in the cloud, if you're going to spin up collectors via AMI, or if you just want to define containers with ECS, you can do that. So there are multiple ways of deploying this, and this is a deployment across two different regions, right? East and West Coast, but you can do it even if you want to have a deployment here on the US and another one in Asia. That's also doable, and it's pretty easy to do. Then another customer reference architecture, it's in case you're doing it on-prem. If you don't have a massive deployment and it's pretty much under your control, and let's say you just have a few branches and you don't see the need to deploy this in the cloud, then you can also do this across different data centers, and without any problem you can handle the traffic across different data centers on what we will call an on-prem solution. Now, the third question that we have, and I think we touched bases on this one.
Okay,
I think I saw the first hand back there.
Actually,
Is how many seconds it takes between the disconnect and connection state flow. Oh, he was the first?
Yeah.
Oh, okay.
B.
It's B. You got it right.
Oh, awesome. Thank you. Yep.
Hey guys, we're not making it very hard, for you. Don't worry, we have more here, right? So we still have 3 more attempts. So even if you don't know the answer, try to raise it very quickly, so you can just read the answer and get to it very fast. Okay, so now we're getting to telemetry design at scale, and this is pretty important because when you're defining your MDT strategy, right, you want to make sure that you get it right the first time, so you don't need to rebuild everything again. Okay, so I will start with a small deployment. Let's say you have 2 to 10 controllers, or even if you just want to start in the lab, right? Testing this in the lab. But if you don't have that many controllers on the network, let's say 2 to 10, this type of deployment can work for you, right? It's just what you need to think about is what we have been talking about already. Make sure that you don't have all your collectors on the same place, and make sure you have a FQDN strategy around how you're going to be deploying model-driven telemetry. So this is a small deployment that it will work for you, as I mentioned before, if you don't have that many controllers, right? Sending data across your network. And just remember, the controllers here are key, right? And remember, if you're doing TLS and MTLS, which we recommend, keep in mind that those certs are going to be exchanging to build that tunnel between the wireless LAN controllers and the collectors, right? That's an encrypted IPsec tunnel that you have between your collectors and the controller, right? In order to send that data across the tunnel, okay? Then another type of deployment, and let's say now, okay, now this is a bit more, at scale where I want to have redundancy and be able to be a bit more granular about how I want to send the data behind my collectors. So in this case, you are now adding a pass-through. So you have two load balancers, one is active, the other one is standby, and now the data is going through the load balancers, but the load balancers in the back end are going to be defining to which of your collectors that data is going to be going, right? You still are managing all those certs between your load balancers and the collectors in the back end, right? As well on the controller side, but now it's the load balancer that is actually managing how you want to send that data across your different collectors that you have on the network, right? And then here, the third one is pretty simple and it's the same. The only difference between the other one and this one is that now you're putting the certs in front of the load balancer. So the load balancers are going to be managing the encryption, right? The tunnel, IPsec tunnel between your controllers, right? And the load balancer. So everything is going to be encrypted until the load balancer. And then in the back end, it can be TCP, right? Between your load balancers and the collectors that you have there in the back end. Now, as we move on, the only difference here is that going to be active-active, right? So the other example was active standby, right? In this deployment, now you have two load balancers that are managing subscription at the same time. This is a pretty good deployment because now you also have full redundancy in case one of the load balancers goes down. And this one is a bit more complex. We are actually seeing customers doing this one where they have front-end load balancers and then they have back-end load balancers, right? So this is when they have a massive deployment of, let's say, tens of collectors or dozens of collectors in the back end. So here they're doing a more granular distribution of how that traffic is going to go from the front end to the back end and then to the collectors. All right? Cool. So now we're going to get into performance and validation, and this is going to be covered by Salil moving forward.
Okay. Thank you, Ralph.
Yep.
Okay. While we have gone over the design aspects, it's always good to try the performance, how it works out. So there are several things that we will talk about in the performance and validation, and then we'll walk through some of the real-world scenarios and a story that actually happened in Cisco Live, and how we used this dashboard to kind of understand the problem and correct it. Okay, let's go back. Okay, so before we go into the design, in terms of the validation, these were the 4 or 5 key things that we thought would be very useful when we design on a telemetry scale. First of all, the controller scale from a telemetry subscriptions perspective is about 150. So Catalyst Center, if you have, will consume about 85 to maybe 90. Cisco Spaces, if you're doing about 10 to 12. So you want to always factor in these numbers if you want to build on top of the existing tools. Subscribe to the closest leaf. I think the lessons what we learned working with some of the big customers, that if you don't go to the leaf level where you want the data, it always oversubscribes and your collectors will overburdened. When we are looking at the controller scale part, you want to make sure that you always monitor the pubd process, and we're going to show you how to monitor that as you scale different XPaths. And especially it's important when you have very high density environment, be it school, college, or even an enterprise where people move at a very high roaming rates. That will impact the performance on the controller. If you, as Raf suggested, the MTLS sort-based gRPC model, if you're doing it, if you have Catalyst Center, make sure things work when the certificates expire or any of those other cautious things. that you would need to take. For the performance and validation, this is what we did in our labs. We had very simple 2 controllers, 3 collectors, 2 databases, and then to show those results, we had the Grafana with some scripts from Jenkins, right? So this is something we have done in our business unit to kind of validate the scale aspect. Obviously, we have the simulator. I think this is a very key one. This is a homegrown built CapWeb simulator that can simulate 64,000 clients, 6,000 APs, and it can basically do as high roaming rates of like 300 roams per second. It can go to 400 roams per second. Similarly, if you connect behind it, the XCR traffic generator, it can actually also generate that 10 gig or 20 gig or 30 gig traffic to kind of mimic. And this is just from the simulation perspective what we had achieved from our labs, so that we wanted to make sure that the team feels comfortable to deploy at a large scale on their production networks. These are the roaming numbers we got from the subscription. We chose about 25 subscriptions. We felt that was a good number considering other aspects on the device. And it's difficult when you have a lot of subscriptions available to look out, which ones to choose. And we've seen some customers really struggle to find the right balance and right ones. What we have put down here are, I think, about close to 20, 25 of them, where you could just blindly pick these without needing to, further dig into these subscriptions. Obviously, 1712 will work if you are on 1712, but we would always recommend 1715.3. And we've also put down some of the scale timelines. For instance, certain XPaths you don't want to do every 60 seconds. You might want to do 15 minutes because there's a scale aspect, and all of those we actually tested in our labs. Okay, all right. Okay, we have a question. What are 3 important design considerations for MDT? Okay, see him there. T, sure.
Which one to go?
I guess not. Do I get ridiculed if I'm wrong?
Someone else gets the chance.
That's okay. Give somebody else the chance.
Okay, good.
I was just looking forward to being ridiculed.
Okay. Yeah, no worries. Yeah, we try to keep it as simple as possible, So, okay, right. Okay, so this is really important real world. How can you actually leverage what we just discussed in real world scenarios? And many of these scenarios actually we have gone through for the last, I would say, probably 2 or 3 years with several customers. And I kind of collected this data to show the importance of why we need all of these. Okay. All right, so before I go in and start talking about these real world, I want to really ask a simple question. I've been working on escalations for almost pretty much my career. And when there is really highly escalated problem, what do you really need to root cause a problem? I think this is a question that I always look at the basics. When you have a problem that's been, like, let's say, not solved for a long time, I think you definitely want to know what changed in the network. This one question actually can solve your biggest problem that exists. And some of the things that I have observed, even having a new member in the team, knowingly or unknowingly has created a problem, which they didn't know themselves, right? So configuration, adding an automation when you think it's just going to pull the data, you're not doing anything on the box, but you didn't know, it's a different team, introduce some new solution, new hardware or software updates. If you can tell precisely what has happened, I think you have nailed like about 80% of the problem. If you are working on, let's say, iOS XE, ShoreTech wireless, send it out to the TAC. It's very useful. If no one's looking at it, the person who has to solve it will look into it. The client debug bundle. If you are working on any of client connectivity issues, I think this is the most important aspect. You could do it through the controller. You could do it through the Catalyst Center. If you ever come to a situation where something happened in the past and you need to root cause, just go and grab these archive logs and then send it out to TAC. The chances are we will be able to understand a lot better than where we are today. So you might have gone through a few sessions on config analyzer or even wireless troubleshooting. There are all of these three things are based on what you have heard in other sessions. The tools, the scripts, they're all built on top of these three things, main things. For what we are working today is the telemetry data or stats. When we get the most complex problem that you could think of, it always goes down to understanding the trends from a statistics perspective. And without having this kind of telemetry information, it's very difficult to tell why a problem happened and if the problem happened, what was the source of the problem. So statistics really plays really important role. Okay, all right. To build this telemetry data or statistics, right? I mean, we've seen a lot of dashboards. People just go in what they need, they build their stuff. It's very useful for them. They can get things around. But I felt these building blocks, 4 or 5, are very essential to kind of understand the trends on the system. It could be a wireless LAN controller. It could be even an IOXC device. These XPaths will work. CPU and memory monitoring. You want to make sure you're able to monitor the process for the CPU, and you also want to make sure you want to monitor the memory. It's very important which process on the box is actually creating the high CPU. Your overall CPU may be always low, but then per process CPU is very important when you look at understanding where the problems are. Control plane in any networking product, not just iOS XE, anywhere. Control plane is the most important aspect. Like what is consuming the most amount of control plane processing time. And in our, let's say, wireless, the control plane could be your mDNS, your probes, your associations, anything that will involve the processing of this data from a control plane perspective. Data plane is almost never touched, but there are situations where we've seen fragmentation. You're probably in a university, you don't know the network end-to-end, someone did incorrect fragmentation end-to-end, and you're now needing to do fragmentation on the box. You've also seen different traffic types. So for instance, if you have packets of low packet size, that's actually going to impact your data plane versus a packet size of 1,500 bytes. The processors are designed such to scale better in terms of the packet size. So that's also very interesting when you start seeing these problems. Client states, you want to know where everything went down at once or only certain sites went down. That's very important to know the client states. The general environmental monitoring, this I call your CPU, not the CPU, but what do you call, like fan status or HA status, I call those environmental variables. RF statistics, if you're in the wireless, you always want to know how is your RF doing. Right, okay. All right, so let's go. Now that we have understood these building blocks, remember the first one which I told to troubleshooting, what changed the network. That will set us how we will debug this problem in the subsequent slides. The first building block, as we talked, CPU memory, I've given this example. What we observe for most part is some of these processes that you have seen, They're the ones actually are consuming most of on the 9800 controllers. So you want to watch out the CLIs, and we've given you the XPaths, and also the sample outputs of the XPaths. Okay. Once you build your dashboard based on those examples, you should see something like this, where you could actually build the processes. This is the WNCD. I'm sure everyone in this room knows what is WNCD. If you haven't, then you're good. You never ran into a problem, but I'm sure everyone on wireless has run into this. So we built this nice little dashboard. It helps. And similarly, we have kind of carved out how many APs are there, and then we can monitor a few processes that we want. So something based on the previous XPaths that I showed you. mDNS, this is a problem when anytime there's an iOS update, I've always seen features actually creating trouble. So for instance, back about 2 or 3 or 4 years back, when mDNS Apple Continuity was enabled, what ended up happening was our controllers by default would broadcast these mDNS across the entire network, unless you actually configure LSS, which is you want to restrict your mDNS traffic locally based on your RF domain. Which what it created is a spike in WNCD, eventually a spike in AP drops, and then you had a cascading network effect. We built a chart for the mDNS traffic so you can visualize what's the trend over your network. Okay. All right, so this is the control plane monitoring. mDNS happens to be one of the important ones, but I felt there would be others that we would need to look at. Some of them are mostly related to your client associations. Your radius packets could be your EAP states, your DHCP states, your ARP. This is all will hit the control plane of the box. And these are the CLIs for the various control plane monitoring. We have given you the XPaths, so you can look at it. And similarly, this is the output from the XPath, so you don't have to try. You can look at the data, how it is. All right. One of the important ones for control plane is understanding the delete reason codes. So when a device or a controller deletes a client, there is a reason given for that delete code. What we have done is we pulled all the delete reason codes from the code, put it into a document, and that document will describe, is it a good or a bad metric to look at? And there's a description about each of those delete reason codes. For instance, this is something that we pulled from the controller, and for something like this is a good inter-instance roam success. That is a good metric to have, but if you look at these red ones, not so good. It's very difficult when you have, let's say, 300 delete reason codes, which ones are good or bad. The URL should explain to you from that perspective. The yellows will create an impact. So something like this you can build on the dashboard. This is an example of once you subscribe to that XPath, build the Grafana chart. You can actually build this tree, something like this. Okay. All right. So radius server meltdowns. Often when it comes in August, September, usually when back to school happens, I've seen nothing changed. Well, students got new laptops, there's a change. No one knew about it. So radius servers, you started seeing timeouts, or they're not responding. Then you start ending up horizontally scaling, or you start adding load balances in front of the radius servers. Now, do you blame the radius servers, or you blame the controllers, you blame the clients, or you blame the certificate authorities that are subscribing to these new certificates? So I feel this is an important XPath to monitor on your network in terms of how many accepts you're seeing, how many rejects are you seeing, how many timeouts are you observing. So that will give you whether it's a problem on your radius servers, the controllers, or the clients. high interferers. So in an event like this, Cisco Live, the rogues, you never know how many rogues people put. It's the most difficult task to find rogues. And sometimes to find out if it's impacting our wireless, you are actually needing to build CLIs and then find out at what point who introduced what rogues. So this is something that I felt very important in your environment, especially if you have a lot of rogues, to monitor using these XPaths. Okay, all right. The sixth one, I think this will be the data plane. Usually you don't get problems on the data plane. If there are problems, usually they have been ended up into fragmentation or sometimes very small packets being consuming like 90% of your data plane. Okay. And if you build that XPath, this is something how you would look like from the XPath perspective from data plane. All right, so I've added some more. We won't go over in details. I like roaming statistics per client. Sometimes you just want to pick few clients and find out how was their roaming history. That can give you some trends. These are the environmental sensors. If you like the temperatures, or you like the fan status, or you like the HA status, you should be building this, something like this. Access point status, if you need to know if its access point is enabled, disabled, radios are up, down, you could use these. If you're really RF savvy, you can do your load, how much load is on an access point, TX and RX, traffic utilization, channel utilization. I think this is the noise and the neighbors. Okay, so the big picture, once you stitch these blocks, you can come up with something like this in your environment. And it could be one controller you might have. You might have, let's say, 4 controllers. You should be able to build something like this. This is another scenario where we built another dashboard just to cater to different use case. And, all right, I think we have one question. Which of the following protocols support a push method to a central repository?
What's the first one?
gRPC. Okay, that's right. All right. All right, so this is something that we use these dashboards in Cisco Live. So I thought I'll show you something that happened in Cisco Live. Not this Cisco Live, but the last one. This Cisco Live has been quiet, but I thought we'll go over this. Let's see. Okay. Pause right around. Okay, all right. So we built this dashboard right here in Cisco Live, and if you look at it, at 10 o'clock, 10:30-ish, people started coming in World of Solutions. You start seeing your CPUs are spiking for these WNCDs, and you're kind of wondering what will happen for the rest of the event. So you have all the executives from IT looking at you at the BU or the NOC teams. What do? Do we reset? Do we load balance? Do we get more controllers? All those fancy ideas. And we basically let the event go for the entire event. And I will explain to you what happened at the end of this video. All right. So if you look at it here, right around, so this was sustained. We were good, like on the border of 80-85%. If it would have reached like 90-95%, sure you'll have client connectivity issues, right? This aspect, if you observed here at around noon, you could see people actually roaming for lunch from one room to another. So high roaming activity getting triggered at that point. Similarly around 1 o'clock, and then it kind of dies down when at around 5:30, when everyone leaves the floor. Okay, let's look at find out. Okay, if I look at here, general trend is all similar, and these are like control plane stats that we built, talked about it. So I don't have anything to suspect here based on what we are observing. So we're trying to root cause what might be going on the environment, right? If you look at the next one, let's see. All right. Okay. So you see here, right around at 12, you see this big spike, and then for the entire duration, that spike didn't exist. So you can zoom in and try to find out what is actually causing here. So you see here the SAE auth invalid PMK ID became astronomically high, right? So remember the question. Every Cisco Live, we do something similar every Cisco Live, but we add a twist to it. We want to try different things, but we want to make sure we do it at the right way. Let's go next one. At least we know that SAE auth is probably what is probably failing, I would suspect. And if you look at here, the total roams at that time were about 41,000. You see the failed roams, which means when clients were roaming from one point to another, they were failing. So there's a high amount of roam failures with these statistics. And when I look at it, oops, I think I pressed it wrong. I need to go back to show you. So you see the failed roams of 19%. And then this is where we did some change the next day. I won't tell it right now, but after the change, what we observed is the CPUs dropped for the next day, and on the next day we had about, on the first day we had about 15,000 clients, and the next day we had about 20,000 clients. So even in spite of that, we basically reduced the CPU utilization to a level where it's in the green zone. This would not have been possible if we didn't have the statistics. If we had to go conventional route where write a script, parse the script, then start looking at what is right, what is wrong, then collect the logs, I think you're looking at least about a week. And while you are in situations like this, you need to be able to act quickly. So you look at the client counts, about 17,000, I guess, yeah. The CPU utilization has dropped, and then it stayed flat for the rest of the evening. Right. Now, if you look at these statistics on the SAE auth, they dramatically reduced by 10x. And if you look at the failed roams, it's about 1%, which is expected. Okay, I need to do. All right. All right, so this is the top part is before, and then the bottom part is after. Do you guys have any guesses what changed? Yes. No? Okay, all right. Any guesses? All right. So we had an interesting question from a lot of customers. Do you recommend enabling WPA3? And we took that chance last Cisco Live. We said, if we don't do it, our customers won't do it. And we enabled the WPA3, except for the fact we did not turn on the fast transition. We did tests with about 30 clients. We found one of the client didn't connect if fast transition was enabled. It was an old Android 10 device. So there's a question, do you actually want Android 10 to work, or you want the conference to be in that state where you have goosebumps, right, how the event would go. What we found out was iPhones didn't do the roaming without FT enabled. So that was the entire event. Most people were with iPhones. So we turned on the FT with WPA3, WPA2, and it worked fine. And we kicked out the Android 10 clients. They were probably about 100 of those, but then we offloaded them to the open roaming SSID. So that's how we basically use this data to make that decision quick. And we were comfortable to tell our executives that nothing's going to break for that day. All right. And this is something we put, I'll just play this video. This is a full building blocks across data plane, control plane, you name it, environmental variables. So it should be, yeah. For the Cisco Live, it built a custom dashboard that we just felt was important, what we needed to look at, but this is something we put in our labs just to get the whole perspective about data plane, control plane, and even from a process memory perspective, process CPU perspective. So it's not restricted only for certain charts. And this is possible with just the basic flow diagram that we showed you, that you can build something like this. These are some of the other XPaths that are connected to the collectors to get this data. We're almost done. So, right. Okay. All right. Okay. That's the right time. So we have a last one. Anyone wants to read? Okay. There you go. Yes. You said B?
Yeah, you said B.
All right. Congrats.
Congrats.
All right. Now, if you felt this was really exhausting, you don't want to do all of this, we have something for you on Catalyst Center, if you use Catalyst Center. So this is something you will see on the Catalyst Center later part in the year. And we won't go in the lab, but we put a demo step by step how to build end to end. It's about 15 minutes video. So I would encourage you guys, if you are interested, go ahead and start trying out. Simple topology that we built, and yeah, this is about, and then we put all the documentation that exists, we have kind of put down here. So if you still feel that you are not getting what you need, please reach out to us, and the demos of these recordings are also there.